Hi, this is Ed McCormick, the University of Washington. I'm working on a PAC-Trans project with Nathan Bells, the University of Alaska Fairbanks, where we're looking at structure from motion on drones, support the monitoring of the risk of roadside avalanches. Many Western states have roads in the mountains with steep snow-loaded slopes above the road, and occasionally these slopes can avalanche. When that occurs, it can block the road, and that can be quite expensive because the DOTs have to mobilize forces to clear the roads, and it really impacts the reliability of the roadway network. It can cause lost queues of vehicles while they clear the road or they do avalanche control, and there's a life safety risk. The avalanches can be powerful enough to blow vehicles off the road or cover them in snow, like this truck in Alaska. Many Western states do try and keep roads open in the winter, so they have to have active avalanche control and avalanche monitoring programs. So they have staff that go out and try and predict avalanche hazards. What they do is they review the weather data and they travel to the field to inspect the snowpack using a variety of ways to get out there, including snowmobiles, skis, and vehicles. Once out in the field, they try and assess the nature of the snowpack by digging snow pits and looking at hard layers, soft layers, and the surface of the snow. And if the conditions are really bad, they need to release an avalanche while the road is being closed. They can use explosives like this howitzer, which, as you can imagine, can be quite risky, quite noisy, and expensive. Our research explored if drones could support this roadside avalanche monitoring process. Drones are increasingly capable, increasingly affordable, and available off the shelf. So our research goal was to explore if we could use structure from motion software on a small drone to support routine avalanche monitoring operations by DOT staff. We wondered if this technology could provide better data, maybe new data they don't have before, maybe more coverage in the mountains than previously before. And we partnered with Washington State DOT and the State of Alaska Transportation and Public Facilities. So you might ask, what is structure of motion? And this is basically photogrammetry software that can develop 3D structure from multiple 2D camera images. It's per person's LiDAR. All you really need is a good camera, which is pretty easy to put on a drone, and some structure of motion software. And it's been used for mapping snowpacks in the past. And we just wanted to know if it could be used routinely by DOTs. We had a number of different test sites in Alaska and Washington State where the DOTs routinely monitor avalanche risk in the winter. We flew those test sites in bare earth conditions, and that gave us a baseline so we could fly them after there was snow, and that could give us data on snow volume, snow depth, and that sort of thing, which is all valuable for the avalanche folks. Here's a flight up in Alaska where we flew Adigan Pass. We collect the images from these flights. We put it into structure for motion software, and you're able to calculate snow volume, snow depth, look at the surface of the snow. We ran this data by the avalanche experts in the DOT, and we were trying to assess how useful it is for them to do their job and make decisions to open or close the road. So our initial findings is that yes, structure for motion provides useful data, but since it's a photographic image, there's limitations due to light conditions and contrast. And of course, the ability to collect structure motion using drones depends on the ability of the aircraft to operate in the mountains in bad weather and rugged terrain. And structure for motion takes time to process, so there's some issues of being able to process the data in a timely manner. But the findings are fairly promising. Drones can cover more area faster than a person on skis, say. You can operate directly from the roadside, so you don't have to leave a vehicle to go up in an avalanche zone, which means it's also safer. There's less exposure by avalanche staff to risky conditions, and you have better data. You can systematically survey avalanche release sites. You can quantify the results, so you can look at changes over time and between seasons. So the bottom line is this technology supports roads that are closed less often and improves network reliability.